Great. Welcome to the BIMstorm wrap-up. We have a 30-minute quick session here to give you an overview of what's been happening. We have an audience online as well. And basically, let's see, I had to restart my slides here, so let me get them up here again. So I thank everybody for participating. We had a lot of activity in the last few days, even this morning, actually, there was a lot going on. So this is the wrap-up session, and we have our team, the Dream Team, that's been collaborating with us both here at the conference at COA in Orlando and a lot of other groups online, including some new examples of things that happened since the first session the other day. So as you all saw, oops, okay, they don't see anything? Okay, hold on a second. Let's see. We're saying that the audience does not see anything online. Okay, how's this? I didn't hit the start button. All right. So we had groups like DROFUS the other day. We had the ONUMA system with programming. We had Beck Technologies. Actually, since the last day, just last night, we got data back from them for cost estimates for the clinic building that we showed the other day. That was in uniformat with more detail, pulled back into the system. So these are two systems talking to each other. The profiler system pushing data back into the ONUMA system of the cost estimate for this clinic. We had Design Atlantic, Devin Jernigan actually going through more detailed analysis and studies of the design of the clinic in multiple tools, multiple building information modeling tools. We showed some live energy analysis the other day, work orders. The work orders, actually, we're starting to see them actually appear more on the plan now, so we actually responded to some of the work orders to kind of simulate the process of how, once we had over 40 work orders coming in from the audience since the other day. So live work orders that you guys submitted them back. We had Ecodomus showing how they can take data from COBE and from other sources, work orders as well, and push it into detailed models and use the Ecodomus system for merging all this data together. This is actually new from the other day. We had CSW bringing in the utility lines into the Foundation for California Community Colleges, a GIS server. So we're merging sources again. They had GIS data in CAD and in Google Earth, and now it's actually aligned with the buildings that we were planning the other day that we showed in the system. A new entry as well, Scarmack Architecture was going through programming and planning of the clinic, a different design. You see the layout there. He did a quick blocking and stacking model. And just to prove that we actually hit bumps along the road, even in BIMstorm, there were some issues with importing and exporting data to another BIM application that he was using. So these BIMstorms actually become kind of a place to test things that work, things that don't work, and you just keep on refining quickly to see how we can fix that. We had over $161 million worth of value of projects essentially designed, different versions of it as well. This is just from the last few days through Balfour Beatty and Scarmack and other teams that were working together. We have these live reports that are coming up. So this is kind of a dashboard view of here's what's going on as the projects are being designed. We had Mike Bordenaro actually. He was watching online and he made commentary on the presentation and actually already posted it to SlideShare, and he's had already 176 views just within the last 16 hours. So it's kind of getting out there. We're broadcasting what's going on here at COA in Orlando. These slides we're actually recorded the session the other day. The SlideShare is online. We're going to be posting links. We're obviously not on the thumb drive because we did all this stuff live, so you will be getting a follow-up email with all the results of what happened here in Orlando. We have Broadus and Associates created a dynamic Prezi file. I'm not going to run through the whole thing, but showing about the handover of going from BIM into operations using COBE and structured data. This is a Prezi file that you can actually zoom in and zoom out and see different parts of the process, and we'll link this live as well from the site. We have Balfour Beatty online. That's going to go next. Are you guys ready to show what you did? I haven't seen anything but yet this morning, but if you're ready to show, we're ready to pass them to
Am I unmuted?
We can hear you.
All right, excellent.
It's a little loud. Maybe we can tone it down a little bit.
Well, I'll
On
see
our
if I can
side
get
here,
my microphone away from my mouth a little bit. All right.
okay.
Can I get control screen?
Yeah, Amber, can you pass it to Balfour Beatty? Jason, is that correct? Is that you? Yeah.
Yep, that's me.
All right. Jason Reese from Balfour Beatty.
All right. So, just so everybody knows, I've had results being pulled together this very morning. I'm literally just stopped working on my presentation, so I have no idea what I'm going to say. Let me switch my screen over to the one you guys can actually see. All right, can everybody see my screen?
Yeah.
All right, excellent. So on Wednesday, I talked about how we were trying to apply rapid design prototyping. I just felt like I should explain that a little bit more. In the manufacturing industry, rapid prototyping means that you basically quickly fabricate a scale model rather than making the metal part that costs a lot of money. You make a, out of plastic or something like that. And there's ways to automate that in the industry. And the message there is the reason why they do that is because failure is an expectation. They're going to get it wrong a lot before they get it right. So that's not unlike what we do with buildings, except for we only can build it one time and we have to work on the fly. So we're very good at doing that, but what we're trying to achieve with rapid prototyping is during the early process of making decisions for a design is how can we quickly develop many different iterations of the design and use that data from those iterations, the results, to have more data equal better decisions. So what we're really trying to achieve is around this blue box right here, where we make one decision. We have three different options, and we have three different options off of that, and there's two options off of that, or three options off of that. And you very quickly have this exponential growth of different iterations of cost versus energy, and all the kinds of impact that you have to the design process. So our challenge to ourselves here with this BIMstorm was, can we use the BIMstorm process to enable this rapid prototyping concept? So the way we're defining rapid prototyping is that we have a rapid energy analysis and we have a rapid cost analysis. Combining those two things together is our rapid prototype. So in order to achieve the rapid energy analysis, we used Enuma, Revit, Vasari, and Excel. And that's pretty much the workflow from one to the other. So through 4 different applications in order to show you the results I'm going to show you there. You get a quick shot from Vasari. These are all the options you have for energy analysis. You can pick high mass construction, low mass construction, high insulation roof, low insulation roof, that type of thing. You have the ability to change the percentage of glass you're looking at. You can put a sunshade on it. And these are some of the things we looked at. And then from that, you get reports that look a little bit like this, but you get some raw data that I pulled through. And then for the rapid cost analysis, we went from Enuma to Revit to Vasari and then to Excel. And again, and you can see right here under the description column that's kind of highlighted yellow in the middle of the screen there, that is our sets that we carried forward that was common between the rapid cost and the rapid energy analysis. So Vico gave us an assist on this one and ran our sets through their software and simultaneously while we were running through the energy analysis. And then we came up with 3 schemes. We had the original scheme that was put out in the Enuma system. That was our baseline. And then we created scheme A and scheme B. And then we created these variables, 2 variables for the roof, 2 variables for sunshades, glass type, and exterior wall. And altogether, when you exponentially grow that equals 32 different sets of possible combinations of all 6 of those things. And that's only looking at 5 different aspects of the building. You have 32 unique ways of looking at the building. And the data we're getting out of our rapid energy and rapid cost analysis is down here, looking at energy use intensity, life cycle cost of the building, and total first cost. So I'm going to dive right in after that intro. I'm diving into the results here, which I really just pasted in here and just started to look at. So this one is taking, actually I think I have a data slide here. There we go. This is a little, I'll orient it. So one of our schemes looks like this. This is set 1, set 2, set 3, and this is the combination of those various options we talked about. And then here's all the data associated with it. This is a manual transfer of data, unfortunately, from the various softwares over to an Excel sheet. But this is how we're able to look at the data and be able to create these nice graphs. So we're looking at the 3 different options that we came up with. first cost versus life cycle energy cost. So we can see very clearly, I think our scheme B was actually a little bit larger, and it was 3 stories, whereas scheme A and B were 2 stories. The original scheme and the scheme A were 2 stories. So you can start to see very quickly that there are some decisions that we could make that put us, $200,000 more over the life of the building. If we want to be down here, we can still achieve a very low first cost. So we don't want to make these decisions that are that are over in the middle of the graph. They're the blue ones. We want to make the ones that are over here. So now we can start inspecting. Now we can go look at annual carbon. We can see a similar type of footprint, so there's not initially new data here, but we know we can achieve low carbon at a baseline for a total life cycle cost. So what does this look like for different options? So if we look at scheme A really quick, what do we see? We see that if I have 40% glass versus 60% glass, where those different sets fall under the scale. So for the total life cycle cost, if I want to have 60% glass in my building, the cheapest I can expect it to be is around this $9.7 million range for scheme A. If I want to try and save some money, it looks like I can save about $100,000 by going to 40% glass and still achieve a relatively low carbon footprint. Now we can look at options for one set and see what happens to that. So if we have the baseline of how much our life cycle cost, when we make the change to the roof, the life cycle energy cost goes down. The cost goes up in these cases, but you can see here that the glazing type is actually the cheapest option, while it actually reduces life cycle energy substantially. So we can very quickly do analysis like this. And then you can go into and you can start getting feedback on what might not actually have a large impact. So if we look at high performance glazing and tinted glazing, there's a clear separation here between life cycle energy costs. There's no real overlap. There's no real good sets that give you the tinted glazing gives you good energy performance. And then same thing with annual carbon. So if you really want a high performing building, you have to use the high performance glazing. And just wanted to wrap up here so that I'm not taking too much time. So I just wanted to outline how long it took to do Scheme A. Scheme A took about 600 minutes or 10 hours of combined time. Now, of course, we were also doing our day jobs, so this took 3 days to do. But we were able, so in about a day, we were able to run that Scheme A analysis. And there's an efficiency gain, so it's not 600 minutes per scheme, because once you set up your system, especially in something like Vico, your second iteration is actually half the time, because you're no longer setting up the software in order to run your analysis. So the second scheme probably takes more in the range of 450 minutes. So to run 3 schemes, we're in the range of 1,500 minutes, or about 25 hours. And we looked at 96 independent sets of information. And typically when we look at buildings doing design, we don't look at anywhere near that amount of information. We're lucky if we can get to a dozen different decision points and options to look at. So now we have a way to gather data and then leverage it to make a more informed decision about how we approach the project from a life cycle energy perspective. And that's all I've got. Come on.
Thanks, Jason. Sorry it was kind of a short time frame, but we're going to be posting more of this information online in the BIMstorm site as far as the results go, and you'll see more from Val Beatty, I'm pretty sure. Okay, so Tony, are you ready?
Yes, sir.
Do you want me to run the slides, or do you want to show your slides?
I'll show the slides from here, okay, because actually
Perfect.
there's been activity already this morning, and so we've updated. We've updated a little bit.
Okay, go ahead. Thank you.
So, seeing me okay?
Yep.
So, hi, I'm Tony Rinella. I'm a director with BIMscore. We're extremely happy to have been engaged with BIMstorm again this year at COA. And as Calvin mentioned when he did the opening presentation, he compared the BIMstorm with Sandy in 4 areas of planning, adoption, technology, and performance, And while we've certainly seen BIMstorm has demonstrated the swiftness and the power of Sandy, as yet has been no destructive effect or intent. We evaluated the process and had an opportunity to compare the results of this active BIM storm with other processes in our worldwide database, and we've been able to produce an evaluation. We started by looking at a baseline project, which is a non-BIM project in the CCC archives. And we found, not surprisingly, no BIM, no plan for BIM. There was actually a small benefit, although BIM was not stipulated. Through 5 phases of the project, 2 model uses were adopted by the design team for energy and for visualization. There were no metrics in order to measure the performance, and the client expressed a little bit of frustration that this project had not been able to take advantage of BIM. So now we look at a past BIMstorm example. BIMscore has been involved with BIMstorm and Onuma in one way or another since early days. So we took a comparison of a project that is not the most current. And again, we ran through the evaluation. We found in terms of planning, there was some limited use at the very beginning. In terms of adoption, there were 3 processes which experienced benefit from the technology, only used during 1 phase, 14 model uses, and some of them actually used integrated analysis. That is, comparing more than 1 discipline at a time in order to arrive at an optimized result. As far as performance, the team noted performance in 5 areas relating mainly to communication and project quality, and they were satisfied. Now we step forward to the COA of today, and we find that there are many more advanced uses of the VDC technology going on in terms of communication, in terms of exchanging models, in terms of saving time, improving quality, and being able to look at more examples, more solutions simultaneously so that the best solution can be adopted. 4 processes are benefiting, still only looking at 1 phase of the project. And again, 14 model uses. In this case, there were 9 specific items that were mentioned by members of the project team. And I won't enumerate them all for you, but I can tell you that some of the new ones were the ability to communicate very rapidly and share model data in order to do some concurrent analysis. The 4th example that we looked at was an example from EcoBuild last year. And the reason we looked at this project is, first of all, although the other 3 projects were academic in nature, this was a medical office building and therefore had different constraints. We also noticed that that BIMstorm ran for a longer period of time and therefore engaged more phases. There were more model uses, including automated optimization made possible by the rapid exchange of data. And we found that of the 8 items, actually, this isn't the right word here. The 8 items exceeded expectation, and the team reported a growing sense of competency. So the goal of BIMscore, of course, is to evaluate and benchmark, but the reason we do that is to provide advice. So we thought it would be fun to run through the BIMstorm results and provide a little bit of advice for the team and for Kimon to enjoy. So the first piece of advice we have around planning is to establish goals and targets at the beginning and mention during the process. So it's possible for everyone on the team to have a clear vision of what the intent is, and then to express these in the 7 areas that you see on the screen now that I won't bother to read to you. the point is to keep everyone focused on the goal and to make sure that we're creating a documented record so that we can later articulate the wonderful things that are actually going on. In terms of adoption, we'd like to see BIMstorm extended to more project phases, and given all the data that are available, we'd like to leverage the BIMstorm into more processes. For example, tightening the synchronization between design and fabrication, and also, of course, continuing past the early design stages. In the technology area, there are so many data available and so many players can communicate so quickly. Our advice is to increase the number of model uses, to leverage more building and site elements, and to leverage design automation tools. And here is a snapshot from the BIM score evaluation. In red, you see the areas which were not touched on, especially during this COA is where this snapshot is from. And you can see that there are many more forms of model use and evaluation that could have been employed. And finally, because the results are stellar, we believe that more frequent, accurate performance tracking so that the team can articulate the value and benefit that's being achieved through BIMstorm would be quite useful. Here's an example of key performance indicators that we've used on other projects, such as the Walt Disney Imagineering projects that you heard Mark Cole speak of earlier in the week. So we like to say that BIM is an excellent tool, and that BIMstorm can help provide the roadmap so that you understand what's available and where you are in relationship to possible goals, and then the GPS to give you an easy pathway and make sure to route you around any obstacles, get you going in the right direction. We're posting all of these evaluations and more at bimscore.com and invite you to come by and have a look. So thank you all, and thanks especially Kimon.
Thanks, Tony. That was great. And as you all know, this was a very short period here. Initially, it was supposed to be a presentation. We started expanding it out to this real interaction. So it's great to see, to push the limits and see how far we can get. Obviously, on a real project, it would be much different than this, but that's great information to have going forward. One thing I'd like to go over, over the last few days, I had some pretty interesting discussions in the hallways outside after my presentation last week, last few days. Oh, we're not seeing the screen? What's that? Oh, okay. Show my screen. Okay. All right. So let me show a few things more. There was a lot of discussions and questions about this particular diagram I showed the other day, about these tools along the bottom and the different teams that need to interact with it and the specialists that use these tools and the need for many different users to be able to touch that data. So that transfer of data from the analysis and the design that happens into an open standards format that can be used by other devices that we talked about, iPhones and tablets. And the one thing about this is, actually, sorry, it's kind of hard to read here, but a favorite quote of mine is from the U.S. Coast Guard: "Transparency leads to self-correcting behavior." That's Admiral Thad Allen. So the more information that people can touch, the more you can actually start reacting. If you can't see the information, then you start creating these train wrecks that you can't react to. That's one point about this. The other point that the Coast Guard makes is the data about our facilities is more valuable than the physical facility itself. This is over the life cycle of the facility. So if you can't get to your information, you're not sustainable in many ways with the data that you have about managing your physical facilities. So in terms of this, one main message that I had the other day is that you really have to own your data. And we'll be posting on our site 10 guidelines of how you as an owner can ask whoever is interacting with you of how to make the data available to you in many formats. And one key point is we want to be able to get it in and out of your tool. So for example, we work with owners and we advise them, when you ask other suppliers and contractors, whatever, we want to actually see that. We don't want to only hear about how it can be done. You actually have to see it happening. Otherwise, you start getting kind of this trap of putting data into a system and not being able to get it out. When I was younger and more naive, I had a pretty fancy car, a sports type car, and my mechanic loved it. You know, and I couldn't quite figure out. I kept asking him, "Is this a good car?" And I had to keep going and getting it fixed. And then he says, "No, this is a great car. It's still good. Keep running." And so every few months, I'd go in and pay to him. And then I realized you can't ask the people that are actually doing certain things. You have to have kind of a balanced view. And I'm going to say this with the intent of, I'm not trying to say that the IT department is a bad thing to have. You have to have that, and you have to have that technology capability. But you, as the owner, have to drive the decisions of what IT is going to do for you, because you can't let IT drive. You can't go to the IT department and say, well, we want to go into this new world of web services and cloud and mobile devices. They're going to say, oh, no, there's security, there's complexity, and there's this, and we're going to keep on using the systems that we manage. So a very important point, a takeaway here is ask the hard questions, just like Cynthia talked about yesterday. If you don't look at the future and say we want to get there, you're going to constantly build on what you have in the past, and then your competitors will just pass you by. So it's that kind of a world now that you can't just expect that to happen just automatically. So the applications that pass information, that we saw some of this examples in the BIM storm of importing and exporting out from one tool to the next, but it's really kind of a file exchange, import-export activity that is great to have, but it doesn't really, you have to have the bigger picture. You really want to have that big view of getting to your data in a way that you can see it in this view right here, to be able to get people to touch that information. Otherwise, you really are losing that value down there. Okay, so one wrap-up thing here at the end is we are still going on. BIM Storm Oklahoma City is still going on. We invite you, it's next week actually. You can actually log into the BIM Storm site. You get access for free to the tools, to the review that's going on. You can even submit projects there. Balfour Beatty actually took the clinic project and landed in Oklahoma City this morning. So they took that same clinic and said, what if we have to reconfigure and do this here? What would it look like? So there's that kind of exercise already happening at Oklahoma City. And in order to drive a revolution, we need this kind of ability to get to data and move quickly. One key point here is that obviously we shrunk this into a few days. Imagine if you had a few weeks or a month. Imagine what you can do with a team like this, with this kind of connectivity, with access to specialists like we had with Balfour Beatty. What can happen to a project in that period? It's actually mind-blowing, because we actually run through these type of exercises on real projects. It's not science fiction. We just showed you a glimpse here. So we will be, we're not on the thumb drive because everything was live, so we will be posting on the bimstorm.com COA site. We'll be sending a link to the COA, that you can post on your site to see more of the results, and we'll be continuing to refine this, because we're using this data actually to do the work that we're working with the National Institute of Building Science with this healthcare initiative with VA and DoD. That clinic actually has VA data in it, so we're using it as a test bed of where can this go. And you don't have to write this link down. We'll send it to you later as well, too, but it has more information there. So BIMStorm COA and the BIMStorm Oklahoma City is bimstorm.okc. And we really want to thank the dream team, as we call them, to jump in this rapid, iterative environment to quickly come up with these different solutions and find potential problems and expand beyond that, as Tony nicely outlined earlier. So thank you very much, and we look forward to hearing more from you as we go forward. Thank you.
The organizer has ended the session, and this call will be disconnected. Goodbye.